Hello and welcome to the Features of Rational Transformations video. Now in this video we're going to start with some rational functions just by looking at the features, so domain and range, x and y intercepts, as well as some asymptotes, and we'll talk about that in a little bit. In the next video we will be graphing, so make sure to watch that as well. Now when we're talking about rational functions, a rational number is just something that can be written as a fraction. So when we're talking about rational functions, you might think of something like f of x is equal to 1 over x. This is the parent function for a rational function, and I'll talk about that a little bit more in the next video. But right now I want to talk about this specific transformation version of a rational function. Well, the general transformation version of a rational function is f of x is equal to a over x minus h plus k. Now, if that a, h, and k seem familiar to you, I'm really hoping they should. When we dealt with transformations all the way back in Unit 2, it's that same a, h, and k. So just a very quick reminder, a is a vertical stretch, so that means we're multiplying. And if there's a negative a, that means that there's a reflection over the x-axis. We have our h value, which is a horizontal shift. If you've got x minus h, it means that you're going to be moving to the right. And if you've got x plus h, it means you're going to be moving to the left. And then lastly, we have k, which is a vertical shift. And if you have a positive k value, you're going to move up. If you have a negative k value, we're going to move down. So I'm hoping that all of these transformations are familiar to us, but maybe we're just starting it with a new function. So in the Go formative that we're going to be working on, each problem has like A through H as part of its question, but most of them are focused on features. So let's just start with problems. We're doing two problems 5 and 7 from the blank notes if you're taking a look at that. And let's just go through all of those features. So let's see, problem number 5. So we'll be going over those transformations a little bit more in the next video, but they're important just to know this format. So if we take a look at problem number 5, that's f of x is equal to negative 2 over x plus 3 minus 1. So we can see that we do have a vertical shift, a horizontal shift, a vertical stretch, as well as a reflection. So the first question, or part A, is going to ask us for a vertical asymptote. Now, just a reminder, an asymptote is like a barrier that you're not allowed to cross. And the way that we find these asymptotes, or specifically a vertical asymptote, these are very long words, so you're going to see me shorten this to VA from now on. But a vertical asymptote, you set your denominator equal to 0 and solve. So in this case, we'll set x plus 3 is equal to 0. And then from here, I'm going to subtract 3 on both sides. We'll get x is equal to negative 3. And there you have it. That's our vertical asymptote at x is equal to negative 3. So when we go through and we graph, I'm going to have a dashed line going up and down when x is equal to negative 3 is like, hey, this is a barrier that you cannot cross. Now, jumping around a little bit, I'm actually going to move on to part E, which is the domain. And if we're taking a look at the domain of a function, well, domain is what are all the possible x values we can have. And basically, the domain is we can have all the possible x values except for the vertical asymptote. So since we know the vertical asymptote is at x is equal to negative 3, we're going to say that our domain is from negative infinity all the way to negative 3, and then we can get really close to negative 3 and all the way to infinity. So because the domain deals with our x values. We're going to have a break in our domain at the vertical asymptote because the vertical asymptote is x is equal to this number. So we're going to be dealing with, I think, only 2 types of asymptotes during this unit. We're going to be dealing with vertical asymptotes, so a line going up and down that we cannot cross, as well as horizontal asymptotes, which is lines going from side to side that we cannot cross. Well, our horizontal asymptote is actually much easier to find, and this will be part B. Again, I know I'm kind of jumping around. Our horizontal asymptote again, I will be shortening that to HA as well, just because such long words. I'm going to take out that colon. So horizontal asymptote, the cool thing is it's just whatever your K value is. So the vertical shift that's moving us up and down, that's going to be our horizontal asymptote. So in this case, in our equation, we can see that we have a -1 right here. So our horizontal asymptote is going to be HA is equal to, HA is y is equal to -1. Do not forget that y is equal to. That's very important to know whether it's a horizontal or vertical asymptote. So taking a look here, that's pretty quick. In transformational form, horizontal asymptotes aren't too challenging to find, but in other forms, we will be dealing with polynomial rational functions over the next few days, and it's a little bit more difficult there. But right here, we only need to look at that K shift, and because this is dealing with our y's, if we want to take a look at our range, which will be part F in the questions that you'll see, our range, remember, deals with our y values. And again, asymptotes are lines we cannot cross. So if we have a horizontal asymptote, it means we're going to have a break in our y values at -1. So our range is going to be from -infinity to -1, and then from -1 to infinity. So we have that break right there because that's where our horizontal asymptote is. So this is a lot of the main features we may not have dealt with before, or maybe it's been a very long time. Remember, asymptotes are barriers we cannot cross. This is how we find all of them. The last 2 features I want to talk to you about are x-intercepts and y-intercepts. So just a reminder for x-intercepts, I'll finish this problem with you and then we'll go through the next one kind of quick. So let's see, for our x-intercepts, that's part C. For an x-intercept, you set the whole equation equal to 0 and solve. So not just the denominator, but the whole equation. So set equation equal to 0 and solve. So in this case, we're going to have 0 is equal to -2 over x plus 3 minus 1. I'm going to start by adding 1 to both sides. So we'll have 1 is equal to -2 over x plus 3. And then from here, I want to get rid of this fraction. So I'm going to multiply it by my whole denominator, not just the x, but by the whole denominator. And the reason I'm going to do that is because if I'm multiplying by x plus 3 and dividing by x plus 3, I can cancel those out. And then I'll make sure to distribute this 1 inside the parentheses on the other side of my equation. Whoops. So I end up with x plus 3 is equal to -2. And then to find my x value, I'm going to subtract 3 on both sides. And I'll get x is equal to -5. Don't stop here. Remember, this is an x-intercept, so we want to write this as a point. So for my x-intercept, this is going to be -5, 0. And that's you're going to find the x-intercept for any type of equation, rational, exponential, linear, anything like that. So that's our x-intercepts. Lastly, we have our y-intercepts, which is part D. So for our y-intercept, instead of setting the equation equal to 0, it's when our x value is 0. So you're going to plug 0 in for x and solve. So in this case, we'll have just our y value, that's what we're trying to find, is equal to -2 over 0 plus 3 minus 1. So we've plugged in that 0. So from here, once we solve, we're going to have y is equal to negative 2 over 3 minus 1. And now there's a few different ways you can write this. You can write your final answer as negative 1 and 2/3. You can write your final answer as negative 1.66 repeating. Or you can write your answer as negative 5/3. All of these answers are acceptable. But this is our y value for a y-intercept. And since it's an intercept, we're going to write this as a point. So it's going to be 0, comma, whichever of these versions you choose to use. I'm just going to use the first one, so negative 1 and 2/3. So these are all of the features that we're going to be focusing on in this video. In the next one, we'll focus on what are the transformations. Let's make a transformation table and actually graph it. So those are kind of all the features. I'm going to go through one more problem with you quickly, just so you can see, oh yeah, this really doesn't take too long. So we're going to be focusing on problem number 7. Move this up a little bit. Let's see, problem number 7 from the blank notes is f of x is equal to 4 over x plus 1 plus 2. So if the first thing I want to find is a vertical asymptote, I'm going to set my denominator equal to 0 and solve. So if x plus 1 is equal to 0, I'm going to subtract 1 on both sides, and we'll get x is equal to negative 1. So a vertical asymptote is x is equal to negative 1. Pretty quick. Then from there, for our domain, means we're going to have a break for whatever our vertical asymptote is. So we'll have our answers from negative infinity to negative 1, with the break at negative 1, and continuing to infinity. Again, because that's our vertical asymptote. For our horizontal asymptote, we're going to look to see whatever the k value is. In this case, I see a plus 2 at the end of the equation. If you don't see anything, it's considered a plus 0. But in this case, I see a plus 2. So our horizontal asymptote is y is equal to 2. And then because that's dealing with our y values, it means that our range is going to have a break at 2. So from negative infinity to 2, and continuing from 2 on to infinity. We can get really, really close to our asymptotes, but not quite equal them, so that's why we're using parentheses. We have that break, because that's our horizontal asymptote. Lastly, we're going to find the x-intercept and y-intercept, and those are all of our features. So again, these can be found pretty quickly. The more you practice, I'm hoping the easier this gets. So I move this up a little bit. Just a reminder, for the x-intercept, you set the whole equation equal to 0 and solve. So we're going to have 0 is equal to 4 over x plus 1 plus 2. I'm going to start by subtracting 2 on both sides. So we'll have negative 2 is equal to 4 over x plus 1. Now I'm going to multiply by whatever is in the denominator, the whole denominator. So I'm going to multiply both sides by x plus 1. So if I do that, I'm going to run out of space here. If I do that, it cancels out over here on my right side. And then on my left side, I'm going to make sure to take this negative 2 and multiply it to the x and to the 1. So I end up with negative 2x minus 2 is equal to 4. I'm going to add 2 to both sides. So I get negative 2 is equal to, negative 2x is equal to 6. Then from there, I'm going to divide both sides by negative 2, and I get x is equal to negative 3. Not done yet. I still want to write it as a point. So we'll have our x-intercept is negative 3, 0. Almost done. One more feature left to find. That's going to be our y-intercept. And we find this by plugging 0 in for our x value. So we'll have y is equal to 4 over 0 plus 1 plus 2. When we simplify this, this becomes 4 over 1 plus 2. 4 over 1 is just 4 plus 2. And we end with 6. So we get that our y value is 6, but remember, write this as a point. So we're going to say that our y-intercept is 0, 6. And those are all of our features. So in the next video, we are going to continue these problems by listing out transformations, making transformation tables, which we've already done before, as well as graphing. So please make sure to watch the next video, and I look forward to seeing you after break.